This resource looks at the origins of the quotient rule in differentiation. Previous videos then introduced differentiation from first principles, and it's logical for us to ask what consequences follow from this derivation. The quotient rule, which is what we're considering here, is a scenario where a function comprises the division of one function by another function. Now, students can skip these explanations and go straight to resource 6 if they're not that interested in first principles derivations. Quotient of functions then. The scenario we are looking at is a function which is one function divided by another function. So here's an example. F of x is defined as 4x squared, that's one function, divided by cos 2x, which is a different function. Or z, or g of w, is 3 sine omega over 2 over omega cubed. So again you see one function in the denominator, a separate function in the numerator. And here k of t, we've got 0.2 t squared in the numerator and e to the 0.1 t in the denominator. So the question we want to ask is, how do we differentiate functions of this type, which involve a quotient or a division of two functions? The core result then. The derivative of a quotient of two functions, and we emphasize here we're only doing two functions, is given by the following formula. So if y is u of x divided by v of x, then dy dx is given by this formula. V du dx minus u dv dx, all divided by v squared. And the way people often say this is a sort of shorthand, is they say v du minus u dv divided by v squared. So if people say that, then you know they're talking about this formula here. So a reminder of the definition of the derivative then. So dy dx is the limiting value as delta x goes to 0 of the difference in the y value, so y x plus delta x minus y of x, divided by the difference in the x values, x plus delta x minus x, or an equivalent formula with other variables. So we're going to use this to derive the quotient rule. So here's our function, y equals u of x divided by v of x, and what we're going to do is plug this into the definition of the derivative. So you'll see all we've done is where we had y x plus delta x, we've written u x plus delta x divided by v x plus delta x, and where we had y of x, we've written u of x divided by v of x. So in other words, we've just plugged it straight into our formula. What we're going to do now is, from the definition of derivatives, we know the following formula. The limit as delta x goes to 0 of u of x plus delta x is u of x plus delta x times du dx. And similarly, the limit as delta x goes to 0 of v x plus delta x is v of x plus delta x dv dx. So what we're going to do is take these two and plug them in to this formula on the left hand side. Now we're going to do that on the next page so we don't end up too squashed. So here's our derivative formula, and here's the two substitutions that we want to make. So we're going to substitute this in here and this value in here. So the algebra is going to look a bit messy, but if you keep a clear head on the steps, all we're doing is substituting those two into the formula. So this is what you get, and you'll notice there's substitution 1. I've got u of x plus delta x du dx, and here's substitution 2, v of x plus delta x dv dx, and then it's got minus u over v, all divided by delta x. Now what I'm going to do next is try and get rid of the denominator in the numerator, if that follows. So I'm going to multiply up by this term here, v of x plus delta x dv dx. So if I do that, and I'm also going to multiply up, obviously, by this term here, v of x. So I'm multiplying up by the product of both. So you'll see in the denominator, I get that product, v of x times v of x plus delta x dv dx, and then I end up with a term over here, u of x plus delta x du dx times v of x, and over here a term minus v of x plus delta x dv dx times u of x. Now, what I've got to do next is try and simplify this, and to do that I'm going to ignore all the delta x squared terms. So, what does this do for me? Well, if I ignore the delta x squared terms, then you'll see in the denominator I can ignore that term there, because that's going to be much smaller than v of x, and so you'll see the denominator just becomes v of x squared times delta x. Next, if we look at the numerator, you'll see I've got a uv term here and a uv term here. So those are going to cancel because of the negative sign in between them. So the numerator is going to reduce to v of x times delta x du dx minus u of x delta x dv dx. And of course what you then notice, use a different colour, is the delta x's will cancel. And when you cancel those delta x's, you get left with this result here, which is v du dx minus u dv dx over v squared, which is our quotient rule. Some examples then. Find the derivative of the following. And all you've got to do is keep a clear head on how you defined u and how you have defined v. So, and then plug the answers into this formula. So you need to know what's v, you need to know what's du dx, what's u, and what's dv dx, and then just plug them into the formula. So here, u is 4x squared, du dx is 8x. v is cos 2x, dv dx is minus 2 sine 2x. So all I'm doing is taking this value here, putting it in there, this value here, putting it in there, this value here, putting it there, and this value here, and putting it there. So you're just plugging them into the formula. So if you can try and keep your work tidy, define u clearly, du dx clearly, v clearly, dv dx clearly, then you can just plug them in. So when I do that, I just substitute them in, and there you see you get a nice neat answer. So dy dx is 8x cos 2x plus 8x squared sine 2x, all divided by cos squared 2x. Now a second example just to illustrate the same procedure, but a different function. So again, remind yourself of the quotient rule so you know what you're aiming for. And here, u is going to be 3 sine w over 2. So du dw is 3 over 2 times cos w over 2. v is w cubed, so dv dw is 3w squared. And again, all I do is plug these into the formula wherever they appear. I'm not going to show everyone. You can see the principle. You just plug everything in wherever they appear in the formula and you get your result. So in summary, this brief resource has shown that the derivative of a quotient requires a particular formula to get simple solutions. And the formula is this. If you write y as u of x divided by v of x, then dy dx is v du dx minus u dv dx, all divided by v squared. And it's a relatively simple formula. Just define u, define v, define the derivatives, and plug in the answers.